They move slowly, silently, unnoticed. To most of us, snails are harmless creatures, inching their way through life, leaving behind a trail of slime. They are seen as symbols of slowness, patience, and even innocence. But what if I told you that something truly disturbing is happening to these seemingly simple mollusks? Something so bizarre, so horrifying, that it seems straight out of a sci-fi movie? Imagine a creature losing control of its own body. Its movements are no longer its own. Something inside it is pulling the strings, turning it into a puppet for its own survival. This isn't fiction. This is the reality for snails infected by a parasite known as Leucochloridium paradoxum. This parasite doesn't just infect the snail, it turns it into a zombie, a biological slave. The snail, which normally hides in shaded areas to avoid predators, is forced to venture into open, exposed spaces where it's easily spotted. But why would a parasite do this? Why would it force its host to commit a form of suicide? The answer is as fascinating as it is terrifying. Leucochloridium doesn't want the snail to survive. It wants it to be eaten. That's the parasite's ultimate goal, to turn the snail into an irresistible target for predators, like birds, ensuring the next phase of its life cycle. And to achieve this, it performs a grotesque transformation that defies the logic of nature. But how exactly does the parasite achieve this? How does it take control of the snail's body and behavior? The answer lies in a series of biological manipulations that seem straight out of a nightmare. The parasite invades the snail's body and heads to a specific location, its eye stalks. There, it multiplies, turning the snail's eyes into pulsating beacons that attract predators. This is the story we're exploring today. A story that takes us into the dark heart of nature, where parasites manipulate their hosts in ways that challenge human understanding. And, as we'll see, this is just the tip of the iceberg. Let's start with the basics. Snails are creatures of predictable habits. They thrive in damp, shaded environments, where they can hide from predators like birds and small mammals. Their slowness is an evolutionary advantage, allowing them to move discreetly and avoid drawing attention. But when a snail is infected by Leucochloridium paradoxum, everything changes. The parasite isn't interested in just sucking nutrients from the snail. It wants much more. It wants to control the snail's behavior, rewriting its natural instincts. What was once a cautious, reclusive creature now becomes a zombie, moving into open, exposed areas where it's easily spotted by predators. But why would the parasite do this? Why would it force the snail to put itself in danger? The answer lies in the parasite's life cycle. Leucochloridium cannot complete its development inside the snail. It needs a larger host, a bird. And to get there, it turns the snail into a living lure. Once inside the snail, the parasite spreads through its body, but it doesn't attack vital organs immediately. Instead, it heads to a very specific location, the snail's eye stalks. These eye stalks, which the snail uses to navigate its environment, become the stage for a grotesque transformation. The parasite fills the eye stalks with pulsating sacs full of larvae. These sacs not only deform the eye stalks but also make them glow and pulsate irregularly. The snail, now unable to hide, becomes an easy target for hungry birds. And here's the most disturbing part: the snail doesn't die immediately. The parasite keeps it alive, allowing its eye stalks to regenerate, only to repeat the cycle again. It's a brutal strategy, but an incredibly effective one. When a bird spots the infected snail, it's drawn to the pulsating eye stalks, which resemble juicy caterpillars. With a quick peck, the bird rips off the infected eye stalks, consuming the parasite's larvae. But the snail doesn't die. It remains alive, with its eye stalks regenerating to repeat the process. Inside the bird, the parasite completes its life cycle. It settles in the bird's digestive tract, where it can reproduce and release eggs. These eggs are then expelled in the bird's droppings, which end up on the ground, where other snails ingest them, restarting the cycle. But what happens to the snail after losing its eye stalks? It doesn't die immediately. The parasite keeps it alive, allowing its eye stalks to regenerate. Within a few days, the eye stalks are back, and the parasite fills them again with larvae. The snail becomes a reproduction machine for the parasite, a biological slave with no control over its own body. This cycle of manipulation and exploitation is one of the most extreme examples of parasitic control in nature. But Leucochloridium isn't the only parasite capable of such feats. In fact, nature is full of examples of organisms that manipulate their hosts in equally disturbing ways. One of the most famous examples is the fungus Ophiocordyceps, which infects ants. This fungus takes over the ant's nervous system, forcing it to climb a plant and bite a leaf. There, the fungus grows and releases spores, infecting other ants. These examples show us that parasitic control isn't an anomaly, it's an evolutionary strategy that has emerged repeatedly in different species. And, as we'll see, this has profound implications not just for animals, but also for humans. Leucochloridium and Ophiocordyceps are just two examples of parasites that manipulate their hosts. But the list is much longer. Consider Toxoplasma gondii, a parasite that infects rodents and alters their behavior, making them less cautious around predators, especially cats. Toxoplasma needs to reach the intestines of a cat to complete its life cycle. To do this, it manipulates the infected rodent, making it lose its fear of cats and even become attracted to the smell of cat urine. The rodent, now reckless, is easily caught and eaten by the cat, allowing the parasite to complete its cycle. But what's even more disturbing is that Toxoplasma can also infect humans. It's estimated that up to 1/3 of the global population may be infected with this parasite. While most people show no symptoms, some studies suggest that Toxoplasma may influence human behavior, making people more prone to taking risks. Some researchers even suggest a link between Toxoplasma infection and mental health conditions, such as schizophrenia. While this connection is still controversial, it raises fascinating questions about how much our behavior can be influenced by microscopic organisms. And if parasites like Toxoplasma can influence the behavior of rodents and humans, what else might be happening in the animal kingdom? How many other parasites are out there, manipulating their hosts in ways we don't yet understand? These questions lead us to a deeper reflection on the role of parasites in nature. They aren't just agents of disease, they are evolutionary forces that shape the behavior and ecology of countless species. To understand how parasites manipulate their hosts, we need to dive into the science behind these phenomena. Parasites have evolved a variety of strategies to control their host's behavior, from releasing chemicals to directly altering the nervous system. In the case of Leucochloridium, the parasite releases proteins that interfere with the snail's nervous system, altering its perception of light and shadow. This causes the snail to move into open areas, where it's more visible to predators. Meanwhile, Ophiocordyceps releases chemical compounds that affect the ant's central nervous system, forcing it to climb a plant and bite a leaf. This behavior is crucial for the fungus, as it allows it to release spores from an elevated position, where they can infect more ants. Toxoplasma, on the other hand, appears to alter dopamine levels in the brains of rodents, making them less cautious and more likely to approach cats. In humans, the parasite may influence neurotransmitter production, potentially affecting behavior and personality. These examples show that parasitic manipulation is a complex process, involving interactions between the parasite and the host's nervous system. And as scientists continue to study these phenomena, they're discovering that parasites may be far more influential than we ever imagined. But what does this mean for us, humans? Are we immune to these manipulations, or are we also subject to parasitic influences we don't yet understand? So, the next time you see a snail crawling slowly, remember, it may not be in control of its own body. It may be a zombie, a puppet in the hands of a relentless parasite. And as we continue to explore the dark secrets of nature, one thing becomes clear: there's always more lurking beneath the surface. Parasites like Leucochloridium and Toxoplasma remind us that nature isn't just beautiful and harmonious, it can also be brutal and relentless. And while these organisms may seem frightening, they are also fascinating, offering valuable insights into evolution and ecology. But perhaps the most important lesson is this: no matter how advanced our technology becomes, there's still much we don't understand about the natural world. And as we explore these mysteries, we must remain curious, but also cautious. If you love uncovering the dark and bizarre secrets of nature, don't forget to like this video and subscribe to the channel. There's so much more to explore, and some of these discoveries might just change the way you see the world forever. Until the next video, stay curious, and stay alert.